Hi everyone, it's Coach Fred here. I'm so glad to be back. And today we're actually going to be talking about something that we have talked about a lot this year, a quadratic function. But I wanted to talk about linear functions for a second. You have gotten so good at dealing with linear functions and understanding them. And what I've been focused on this year is that there are many ways we can write a linear function, and we call those the equivalent forms. So I want you to give yourself a second to think about what those three equivalent forms of a linear function are. So take a second and think about that. All right, so I'm hoping as you've thought about that, you came up with all three. If not, here I'm going to review them. So the first one that we spent a lot of time working on was slope-intercept form. Slope-intercept form. And slope-intercept form was in the form either y equals mx plus b. We could write it as y equals b plus mx. But it was always in the y equals form. It provided me with the slope, which was m, and 0b, the y-intercept. Now, we made that a little bit trickier when we introduced to you f of x. So it could look like that as well. But you should feel pretty comfortable with slope-intercept form. The next one that we spent some time in was point-slope form. Point-slope form. And point-slope form was y minus y1 equals m times x minus x1. And this form of an equation I really like to write equations of lines in. And m is still the slope. And x1, y1 represents a point on the line. So we use this when we were writing equations of lines or even graphing equations of lines. And then the third one, which we've gotten more comfortable with, was standard form. Standard form of an equation of a line. Okay, and so that's in the form ax plus by equals c. Now, remember we talked about the fact that a needs to be an integer, so it can't be a fraction. So we always want to make sure a is an integer at the end if we've got something in standard form. Some books say it has to be a positive integer. Some books don't. I'm not really, I could care less either way. As long as it's an integer, then I know it's standard form for me. When do I use standard form? Well, I like standard form. Standard form comes up a lot when we're working with systems of equations, but it also is a quick and easy way to graph a line. And remember, we graph in this form, we graph using the intercepts. And this year we've also investigated the fact that if you're looking at a standard form equation, you can easily find the intercepts, make a quick table of values. Let x be 0 to find the y-intercept. Let y be 0 to find the x-intercept. But you can also find the slope. And we investigated what happened when we took standard form and we put it into slope-intercept form. And we found that no matter what, the slope would be a negative a over b. So a negative a would be the constant of the x, and b would be the constant of the y. All right, so you should feel really comfortable. These are all the exact same equation, just written differently, right? Equivalent means equals, means is the same as. Equals will always mean is the same as. But that doesn't mean we can't write things differently and then still give me the same type of information. All right, but I said this today we were going to be talking about quadratic functions. So let's move on. And here we have hashtag parabola. You all should feel pretty comfortable with a parabola. But I just want to talk about the parts that we've spent time working on this year. So this part right here, we call kind of the bottom, or over here we'd call it the top. But the mathy name for that is called the vertex, okay? And this vertex, we would say, has a minimum value. Okay, it has a minimum value. Why? Well, because if I think about the graph, it doesn't go any lower than that. So that's the lowest point it could be. Whereas this vertex over here, still a vertex, it has what we would call a maximum value. Well, why? Because that's going to be the highest point that we could see on this graph. All right, it also has some other features that we want to be able to look at. If we put a pretend mirror going right down the middle, then we can see clearly that it has symmetry from that line. So every point on the left has a corresponding reflection point on the right. So we call this the axis of symmetry. All right, now on the one on the right, you might see there's some other points that we've got. I see right here, I've got x-intercepts. And again, they are equally distanced from that axis of symmetry. So any point on a parabola can be reflected over that line. Now we're going to spend a lot of more time on the parabola, but I wanted to really spend today just introducing to you and reviewing the equivalent forms. So here we go. Quadratics, just like lines, have three equivalent forms. Again, you might be looking at these graphs and noticing that all the graphs are exactly the same, but the equations that are the names of those graphs or that represent those graphs are all different. So we have a standard form, because like I told you when we were working on standard form of line, we have a standard form for every function. This one also has something like we call vertex form. And the last one, I actually call it factored form, but most books are going to call it intercept form. And if I was really going to get technical, I'd want to call it x-intercept form. Remember how I liked slope-intercept, and I liked to call it slope-y-intercept form? But I really like to call it factored form because that's what it is. It looks like standard form, but after I factored it. Now I want you to just take a minute. I'm going to give you about 50 seconds to really look at these graphs. So press pause, take 50 seconds, and look at the equation and the graph and what you notice. You notice about all the numbers, all the constants in front of each of my terms or with the x's. What do you notice about the constants and the graphs? Okay, so you're back. You spent your 50 seconds. Let's look at each one. Let's see what you noticed. Well, in standard form, I kind of noticed that this number was -3. Where did I find -3 on the graph? I found it right here. And so we remember that if I want to find the y-intercept of any function, we set x equal to 0 and solve for y. So what works out happening is that value, that last value, that constant value in a quadratic, always works out to be the y-intercept, because if you let x be 0, you get 0 plus 0 minus 3. You get that y equals -3. So the point 0, -3 is always on the graph. So in standard form, I actually can see that. Okay, you might also notice that this graph opens up. We've talked about that this year. The reason it opens up is because the coefficient in front of the x squared is positive, okay? So that tells, I knew it opened up. That means that I know there's another point on the graph somewhere on the right side or somewhere on the left side of the graph, that's the symmetrical point to that -3. All right, we're going to talk more about it. That's all I wanted you to see from this is what point could you see directly from looking at standard form. All right, vertex form. Well, I just like the name. I mean, vertex form. What do you think it's showing me on the graph? Well, hopefully you saw that vertex form. Actually, let me make this a little bit smaller so you guys can see it all in one. There we go. Vertex form. Well, I noticed that this point, this vertex right here, was the coordinate point 1, -4. Huh. I see a 1 and a -4. I see a 1 here, although it looks like it's a -1. And I do see a -4 here. So vertex form tells me the vertex. Now, the one thing you have to really think about, though, is that 1 that we got, if you want to think about it as the opposite value, or if you want to think about it the value you'd have to put in for x to make this quantity 0, that's another way you could think about it. But yes, it gives me the vertex, and it's always going to be change sign, keep sign. So I love vertex form because I automatically know where that vertex is. All right, let's look at the last form. I love this form. Factored form, remember I called it x-intercept form. We spent a lot of time factoring this year. What did you notice? Well, I see 1 here and I see 3 here, but I see positive 1 here and negative 3 here, but I see 3 and negative 1 here. Well, that's true. Now, I want you to think about the zero product property for a second. If this were something that we factored and I said solve for x, well, you would use the zero product property by setting the function equal to 0 and then setting each factor equal to 0 to solve for x. X minus 3 equals 0, so x equals 3. These two values, which are always the opposite of your factors, look, those are my x-intercept. So in factored form, I can actually see the x-intercept. What's even cooler then is that I know if I have 2 points on the graph that are equally distant from a line of symmetry, I know that the line of symmetry has to be in the middle of them. So although that doesn't tell me everything, it does tell me where my x coordinate of my vertex would lie. Not my y, but where my x coordinate would lie. So these are the 3 equivalent forms of a quadratic function. Let me go over it again. Standard form. Standard form tells me the y-intercept just by looking at it. It's a constant in the equation. Vertex form tells me the vertex of my parabola. Those numbers are constants in the equation. And factored form or x-intercept form gives me the x-intercepts of my quadratic or my parabola. So each of these tells me something different and will allow me to find all the other features on the graph, which is what we're going to be spending time on this week. We're going to start by taking a really good look at vertex form. All right, guys, that's it for today. I just wanted to give you a brief introduction into what we're going to be looking at and the forms of the quadratic function. I hope you have a great night.